another is the relative method. Okay. Now in ICR method, there are different steps to find out the velocity. Okay. Means for example, you have to draw the configuration diagram. Then you have to find out the number of links. Then you have to find out the number of ICRs. Then you make a list of ICR. Okay. Then you have to mark the ICRs, those who are known by inspection in the space diagram. Then next one is you have to find out the ICRs which are unknown. Okay, then you have to find out the velocity and angular velocity of the respective link. Okay, now see the next one. Next is the relative velocity method. Now in this relative velocity method means what? There are two methods. There are two types of velocity. One is absolute velocity and another is the relative velocity. If you consider there are 2 points. Okay, now suppose consider this is the line. Now here is the point A and here is the point B. Okay. If the velocity of A is given, if the velocity of A is given in this direction, velocity A, and the velocity of B is given in this direction. Okay, now the velocity A or the velocity of any point is known as absolute velocity because the motion of that velocity, that point takes place with respect to a fixed point, and velocity of B is also absolute velocity. If you consider here the velocity of B with respect to A, means what? There is a relative motion of this B with respect to A. You have to consider the velocity of B relative to velocity A. Now it is known as a relative velocity. Okay, if the velocity of any point with respect to corresponding point, we have to consider it is a relative velocity because there is a relative motion between them takes place. There are two types of velocities, absolute and relative velocity. Okay. Now first of all we will take a first example. See here, consider the two bodies A and B moving along a parallel line in the same direction with absolute velocity of point A is given. Okay, and velocity of B is also given. Suppose you have to consider here the velocity of A is given here 4 meter per second, whose direction is given shown in figure, and magnitude is 4 meter per second, and velocity of B is given here 2 meter per second. Okay, now you have to draw a vector diagram. Now you have to draw a vector diagram, or you have to represent these velocities by using a vector diagram. For that I will take here the scale. Okay, for that I will take here a scale. 1 centimeter is equal to, suppose, 1 meter per second. Velocity is a vector quantity, it having a both magnitude and direction. Okay, we know the direction, it is parallel, both the velocities A and B are parallel to each other. Magnitude of velocity A is given 4 meter per second and velocity B is given 2 meter per second. Okay, now you have to draw a vector diagram, or you have to represent this velocity by using a vector diagram. You have to take down a scale. 1 centimeter is equal to 1 meter per second. Okay, now you have to consider the motion of both the particles A and B with respect to some of the fixed point. You have to consider the fixed point O, and both the bodies move with respect to O point. Okay, now how to draw this vector diagram? See here, first of all you have to take down the fixed point O, or the locate the fixed point O, see in the figure. From that fixed point O, you have to first of all draw a velocity A. You have to draw a velocity A. I will draw here velocity A, which represents the vector OA. Vector OA. And its magnitude is equal to how much? Its magnitude is equal 4 meter per second. According to scale, you have to write down in centimeter, it is equal to how much? 4 centimeter. Okay, means I will draw first vector OA 4 centimeter, whose direction is known here. It is a horizontal line. So through this O, I will draw a horizontal line in the direction of arrow. Again, you have to draw in the direction of arrow. Arrow means towards the right hand side, whose magnitude is 4 centimeter. Okay, OA, vector OA. Okay, now next vector you have to draw, or you have to represent the next velocity B is equal to vector OB is equal to, magnitude is given here 2 meter per second, is equal to 2 centimeter. In terms of centimeter, you have to draw a vector OB 2 centimeter. Again, you have to take down the fixed point. Okay, take down the fixed point O. From this O, you have to draw a 2 centimeter line, which is your vector OB, which is nothing but your velocity of B, and the direction is given again parallel to the OA. And through this O, you have to draw another vector on the same line, whose magnitude is your 2 centimeter, and this is your point B. Okay, now this is the velocity B, and OA represent the velocity A. OA represent the velocity A, this way. Velocity A. Okay, in this way you have to draw a vector diagram with scale. Okay, now suppose you have to find out the velocity of A with respect to B. You have to find out velocity of A with respect to B, or relative to B. Okay, and find out the velocity A with respect to B. First of all, you have to take down the velocity A minus velocity B, or you have to represent by using a vector. You have to take down the vector AB. Vector AB is nothing but velocity A with respect to B is equal to, velocity A is your vector OA minus velocity B is your vector OB. Okay,
So वो क्या लिखा है?
हाँ,
So वो AB बार के ऊपर क्या लिखा है, मतलब वो VA